So I'm going to give you a couple examples here from your homework so you can, if you're having trouble with this, you can come back, look at this little video, and maybe it'll help you with your homework. So this is from lesson 7.5, and this is parallel lines and how they help you figure out whether a triangle is similar or not. Okay, so here we have triangle X, Y, Z, and then we actually have another triangle within it. So we have this large triangle, then we really have X, M, N as well. And it tells us also in this triangle with these arrows that these two lines are parallel because of those arrows. And then it gives us some basic measurements, and it might not initially say X, but I'll show you how to solve for some unknowns. So in this one it says if XM equals 4, so if I was going to rewrite this, it'd probably be the best thing to do here. And I might not write them perfectly parallel, and that's perfectly fine as well. Okay, so if I redo this, X, M, Y, Z, and N, don't worry about this X here. But, so if I rewrite this and it says if XM is 4, that's right here, this is 4, this distance right here. And XN is 6, so that'd be this distance right here. And NZ is 9, so this distance here. So then that would tell us the total distance is 15, right? Find XY, which is this whole distance here. Okay, so this wouldn't be too hard to do. We could do make this X, or probably the best thing to do is to make this X. Okay, if we wanted to figure out XY, then we would then know that XY is 4 plus X. Okay, so then we can use all this data or this information we have to form a ratio. Okay, and we know some ratios such as XM, which is 4. I'm just going to write out the ratio first, and this ratio right here should compare to the entire ratio of the larger triangle. So XM, we would compare that to XN, and then we would make it equal to XY. We want to make sure these sides are the same, matched up here, and then XZ. Okay, and then we'll plug in our numbers for this. So XM is 4, XN is 6, and then we know XY is going to be 4 plus X. I want to do that sideways whenever I do that. And then this one would be 6 plus 9 is 15. Okay. Then we would do our math, and we would just say 15 times 4 is 60. That equals 6 times 4 is 24 plus 6x. Okay, then we're going to minus 24 from both sides. That's going to give us 36 equals 6x, and x equals 6. So that would tell us that this side right here would be equal to 6. And the whole side would be 10. 10 compared to 15 will be the same ratio as 4 compared to 6. So that's one example. Okay, we could do another one here, and we could do the same thing, a little bit different here. We'll just add this just to give you one more example. Okay, so we have this triangle again. We have X, Y, Z. This is M, N. Then we want to figure or fill in what we know. XN is 6. XM is 2. And then XY is 10, right? The whole thing is 10. Okay, so then find NZ, this shorter one here, right? So if we kind of don't know what NZ is, we'll call it X. Okay, but then we do know that the whole thing XY is 10 and XM is 2, so this should be 8, right? We can kind of fill that in. And then we just want to make some ratios like XM compared to XN. And then we'll make that equal to MY compared to NZ. Then put in our numbers, 2 over 6. That should equal X, we're going MY 8 over x. We don't know what it is, right? Okay, so then we're just going to go 2x equals 48, and then we're going to divide by 2. Seems like a big number, but we'll see. X equals 24. Okay, but this is a big number here. It's like 1/3 of that, and then we make x equal to 24. And if we just played it out, 2 to 6 over 8 to 24, this would be 1/3, and then this would be 1/3. So they're true. They are the same ratio. So those are two examples. Hope that helped you if you weren't sure how to do these problems, and see you in class.